is Tommy, and today we're talking about concentration versus time. Label each set of graphs with reactant A's order. So, for the first set, we can see that we have concentration of A versus time, natural logarithm of concentration of A versus time, and 1 over concentration of A versus time. And only concentration of A versus time is linear. And notice it's decreasing, so that signifies that A is 0th order to the reaction for the first set of graphs. So it is not included in the rate equation, it's just rate equals K times any other reactants that might be in the equation that actually matter. So, for the second set of graphs, we can see that all of them are nonlinear except for natural logarithm of concentration of A versus time, which is decreasing linearly. So we can determine that this is a first order reaction. Well, not reaction. A is first order to the reaction, so it's K times concentration of A times, again, other reactants that might matter in the equation. But right now we're just looking at concentration of A, we're not worrying about those other ones. For the third set of graphs, we have concentration of A, natural logarithm of concentration of A, and 1 over concentration of A, where only the reciprocal of the concentration of A is linear, and that denotes a second order reaction, where concentration of A is squared in the rate equation. For this problem, we have to find the rate constant for the decomposition of element Y. So we see that at 0 seconds we have 0.1 molar of concentration of Y. So if we want to find where we have half of that. So half of 0.1 is 0.05. So we have that. Here we have 2. So we know our half-life is 2 seconds. But we also have to make sure that the reaction is indeed first order. And the way you can do that is by seeing if the half-life is constant. So if half-life is constant, we would expect at 4 seconds we would have molarity of 0.025. So we go to about 0.025. And that brings us to 4. So our reaction is indeed first order. So now that we know that we have a half-life of 2 seconds, we can come over here. 2 equals 0.693 over K, or K equals 0.0693 over 2, K equals 0.3465. So that's how you find the rate constant for a first order reaction with a constant half-life.